Hello, everyone. This is Mr. Beckstrom, and today we're going to be talking about the quadratic formula. Now, this is a formula that is taught usually in high school, and you'll also need it here in college. And what makes it special? Well, the fact that the quadratic formula will solve any quadratic that you have is great because we also learn factoring methods. And if something can't be factored, there's only two ways to solve those types of equations. One of them is the quadratic formula, and one of them is completing the square. Those will always get you solutions to your quadratics. So let's take a look at an example, and we'll see how we can apply this formula in order to solve the problem. So let's say we have 3x squared minus 2x plus 17. All right. And we want to first, usually we'll try to factor this. So if I was to split this up, 3x and x, and we know that we need to find two factors of 17. They're only going to be 1 and 17. So if we try to mess around with those, we put the 1 here, the 17 there, actually negatives. We'll see that there's no way we can get that -2 in the middle. So what we want to do with this type of problem is apply the quadratic formula, or once again, and this is going to be set equal to 0. Or you can use the completing the square. And I'll tell you right now that most students prefer the quadratic formula. So how do we use that? Well, we first have to get this in the standard form. And this is where our x squared term comes first, our x term comes second, and our constant comes third. And then we have it set equal to 0. So if there's any numbers on the right-hand side or other terms, you want to move everything to the left-hand side so you're set equal to 0. And what we're doing is we're finding the solutions of this second degree polynomial, which is also called a quadratic, using this quadratic formula. All right, so let's go ahead and get started. The formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So this is what we're going to use in order to find the values of x that make this equation true, right? So we first need to identify our a, b, and c. So once we have it in this standard form up above here, where the x squared term comes first, the x term comes second, and the constant term comes third, then we can apply this formula. Well, let's first suppose that one of these terms is not there. So we have to have this first term with an x squared where our constant is a non-zero in order to apply this at all. So we do have to have the x squared term, but we don't have to have the x term and we don't have to have the constant. So let's say we have a 0 or a 0 for the coefficients of the second two terms there. Um, well, what are we going to do about that? Well, we can still apply it. We just set b and or c equal to 0 in those cases. But here we actually have all three terms, so we'll have all non-zero answers for a, b, and c. So let's write those down. So a is going to be the coefficient in front of your x squared term, which is equal to 3. Your b is going to be the coefficient in front of your x term, which is -2. And your c is going to be your constant there, which is 17. And now we're going to just plug and play. We're going to take these values and we're going to plug them into the quadratic equation and get our solutions. So one thing that I see students will make mistakes on very often in tests is this negative part here. So if you have to take the negative of a negative number, that's actually going to become a positive number. So remember to do that. So what I'm going to do is I'm going to write it like this. This is -2 plus or minus the square root of b squared, so negative 2 squared, minus 4 times a, which is 3, times c, which is 17, which is 17. And this is all going to be over 2 times a. So 2 times 3 here. All right. So we plugged everything in, and now we need to work it out. So let's see if I've got some space here. I will kind of work it up in this corner here. So a negative of a negative 2 is a 2. So we have 2 plus or minus the square root of 4. Negative 2 squared is 4. Another thing that I see quite often is that when students put a negative 2 squared or a negative number at all squared in their calculator, they often get a negative number back. So when you square a number in your calculator, make sure that you put parentheses around the number. So we have 4 minus, well, what is this here? This is going to be 17 times 3, which is 51, and 51 times 4 is going to be 204. So we're going to have 4 minus 204 all over 2 times 3, which is 6. So we can already see something happening. Our discriminant is this part right here. It's the b squared minus the 4ac. And if that discriminant comes out to a negative number, then that means our solutions are imaginary. And that also means that the curve is not going to cross through the x-axis. So if we look at this, this will be 2 plus or minus 4 minus 200 is negative 200 all over 6. And I'm going to erase this part right here. All right. Remember, if you have a negative number and a square root, you can pull that negative out and call it an I. Remember, I is equal to the square root of negative 1. I'll put that right up here. Square root of negative 1. So we can now rewrite this as 2 plus or minus, check my time, plus or minus I times the square root of 200 all over 6. Well, we can still work to reduce this. So let's do that. So 2 plus or minus, and 200 can be written as 2 times 100. And the reason we do that is because 100 is a perfect square. So we can pull that perfect square out of there. So we'll still have the I, and then we'll bring out um, the square root of 100, which is equal to 10. And then we'll do the square root of 2, which is left in there, all over 6. Now, usually we'll put the I on the right side of our constant, so our final should look like, and I'm going to divide out a 2 from each one of the 3 terms there. So that leaves me a 1, a 5, and a 3 down here. So our final answer will be 1 plus or minus 5i times the square root of 2 all over 3. So this is actually 2 solutions. One of the solutions is where I use the plus sign here. So that would be 1 plus 5i times the square root of 2. And the second over 3. And the second solution would be where I use the minus here. So that'd be 1 minus 5i times the square root of 2 all over 3. Well, I hope this helped today. If you have any questions, please let me know, always through email or Canvas discussions, and we'll be checking those. And I hope you have a great rest of your day. Thank you.